Like before I share my screen?
Yeah, so
Okay.
hello everyone, and thank you for joining today's session on tools to use to improve your performance of Azure SQL Database. And today we had Deepthi, who is a Microsoft Data Platform MVP, and who is also a Microsoft certified trainer, and who will be walking us through the topic and helping us better understand how you can improve your SQL databases on Azure. And before I give the mic to Deepthi and get started with session, I wanted to include a few things about today's session that the session will be recorded and secondly, there is a certificate of participation for those who stay till the end. So in order for you to receive a certificate of participation, you need to fill out the form that I'll be sharing in the chat box, and you can fill it out and you should directly receive a certificate of participation. And if you want to be participating in our upcoming sessions or any trainings that we'll be conducting, please to join the community, which I'll share the link as well in the chat box. With that, I'm done here and I'm moving all the control to Deepti to introduce herself a little bit more and going into the session. Over to you.
Thank you, Suraj. Let me share my screen quickly. Um, all right. So you are able to see my screen, right, in the presentation mode?
Yes.
Awesome. Thank you so much, Suraj. First of all, thank you everyone for taking your time for attending this session today. And good morning, good afternoon, good evening, depending upon where you are joining from. Myself, I am Deepthi Kokuri. Today, I'm going to discuss on the topic like performance tools in Azure SQL Database. Um, but before beginning, I would like to really thank Suraj from the bottom of my heart for giving me this wonderful opportunity. This is my first time ever presenting for your community here, and I hope I'll do more in future as well. So yeah, I'll give a little bit of introduction before moving forward. Myself, I'm Deepthi Kokuri. I have been a database administrator all my life. I have about like 8 years of experience as a database administrator, and I'm a Microsoft data platform MVP, and I'm also a co-organizer for a couple of user groups. I'm a co-organizer for data DEI, diversity, equity, and inclusion. Just a moment. Diversity, equity, and inclusion user group, and also Microsoft Data and AI South Florida user group. And I recently joined a new user group as a co-organizer. It's known as Data TGIF. It is from Germany, and I do it virtually. So I live in United States, by the way. So I do that virtually, and also I do volunteer for the data platform Women in Technology user group as well. And apart from my actual job as well as my community work, I love doing arts and crafts. It makes me happy to do something from scratch. um, so if you have any questions regarding this session later, you can put it in the chat box so that Suraj will be looking into, and later after the session we can go through those questions. But if you're shy and couldn't ask here, you can definitely contact me on the Twitter. At dbnuggets is my user ID, and dbnuggets.com is my website where I usually blog about SQL Server, Azure topics. So if you'd like, you can go ahead and look into it. As well as if you're on LinkedIn, you can contact me. It will be an honor to get in touch with you. Search by my name, Deepthi Gogri, you'll find me. So when do you call it as a performance? Like you have an application, front end application, um, and backend, you say, let's say we have a SQL server or Azure SQL database, let's say, like, but when everything works fine, nobody will even talk about it, right? That they won't even say like, hey, performance is superb, because we are always striving to do like to run faster queries all the time. So when does it call as performance is when you will not receive the service calls saying that the performance is slow. The queries run fast, and all of your, which indirectly says that all the capabilities that you have on the server, that built on the server, like CPU, memory, IO, are in place, and that's the reason like your queries are running faster. But on the other end, when do we call it as slow performance? like if somebody, like from the application perspective, like from the front end, if they click on something, like let's say a button, they are trying to insert some data, let's say shopping, they are trying to put something in the shopping cart, and that's a shopping website, and if it is not going through, right, something is happening behind the scenes, and most of the time they say like website is down, and by the time we get the call to the service desk, they say like website is totally down. And then internally within the company, most of the time, like because I'm a DBA, I know that they say like database is down. No matter what the problem happens in between, like from the web application, if you see, there are too many layers. There are API layers like network, servers and storage, and then databases and capacities. There are a lot more things to be concerned about, but they just throw it on the database administrator saying that database is down. So more when we talk about the database, there are like many things that we need to take care, because ultimately the application will actually run the queries. Those queries are run on the servers, right? No matter if it is in Azure or in the on-prem databases. So when the queries doesn't run faster, everybody screams at it, and then we get too many calls. That's when we need to actually go ahead and look like which layer, where in between, which layer is having the exact problem. So when we talk about the database perspective, right, even if it is in on-prem or in Azure, if you are trying to build a new application, let's say, and as it is a new application, we just need a one database which can support that application, let's say. Most of the companies are preferring to create the databases in Azure, because like we do not have to maintain any hardware, right? We can just go ahead and scale up and scale down and use the resources as we need. So, but no matter if we create a database on our on-prem SQL servers, where we purchase the capacities like CPU, memory, everything ahead of time, and we actually purchase them, right? No matter if we do that or in Azure, we need to make sure we have certain capabilities so that our application will run faster. So, what are the basic main factors? Like we talked, those are the maximum capacities, which includes the CPU, memory, IO. When we talk about the queries itself, indexes are very helpful. No matter if your database is on-prem or in Azure, we have those tables, and tables have indexes to run the queries faster, and indexes are being used just to query for the get the results. They won't be useful much for the inserts, right? To retrieve the data, indexes are really helpful. And if you are using in-memory OLTP systems, business critical databases are the only way you can use the in-memory OLTP systems. And today in this session, we are mainly going to focus on the intelligent performance, because intelligent performance is especially in Azure. So what are those capabilities and what are the features? And let's dig into them today. So in this session today, like as we move forward, right, I just want to put it out there that what can you expect by the end of this session? Like this is not like a 500 level session. This is not like if you are starting your Azure SQL, like if you are starting your Azure journey, or if you are in between the um, Azure learning journey. And if somebody asks you from your company, like what are the capabilities that we have to improve the performance, then by the end of the session, you'll learn like what are those features and how you can actually use them. So that is what you will receive by the end of the session. So like before beginning, I would like to give you an overview. Most of you have already known like what are the tiers that are available in Azure, but this is like a um, uh, one-stop shop, like kind of like what are the maximum capacities that are available in all the different tiers: general purpose, business critical, hyperscale. Like I said, if you are going to use in-memory OLTP, business critical is the only choice you have. You cannot use the other tiers. And you will see like what are the other maximum capacities available. I'm not going through this slide like each and every service tier here, but you can look into this page, and then you can understand the capacities that are available. So TempDB, we use TempDB for the queries. Your queries while they are running, if they have to put the data somewhere temporarily, they use the TempDB. So in Azure, if you are building your database in Azure, you can certainly choose the size and the number and the location where you are going to, like, you can choose the number and the size of your TempDB, but you cannot exactly tell where you have to put this TempDB, because all you get is a database when you choose the Azure SQL database. You do not know where the TempDB is located. And always in Azure, the TempDB are located in the local SSDs for the faster performance. And if you are using Azure SQL database, the maximum number of files that you can have for the TempDB is 16 files. But if you are using the managed instance, you can use maximum up to 12 files. And there are certain database configurations that you can use, like alter database scope configuration, and the database itself will always be in the full recovery model for the Azure SQL database because of the service level agreements from Azure. And mainly like Maxtop, you can use the Maxtop, and not just like the way you use Maxtop on-prem servers. But the thing is, like, you have something known as query store, which we are going to discuss. That is one of the best features I can say that is currently available in SQL Server. You can actually use the Maxtop as a query hint regularly on-prem SQL servers, but with Azure and with the query store feature, there is something known as query store hints, where you do not have to change any underneath code of your query, but still fix the query very quickly by using these query store hints. Again, we are going to talk about that in the coming slides as well as in our demo. And regarding the files and file groups, you can like add and change the file sizes, as well as you can in Azure, right? You can still use the user defined file groups. Now, let's talk about the basic things here, like indexes as well as statistics. If you're a developer or a DBA or a professional who works with the tables, you need to know about these two important things because they directly impact your performance of your queries. Now, you might be thinking like, we already know about indexes and statistics, but let's talk a little bit about like what exactly happens behind the scenes when we use indexes as statistics, and what actually happens when we submit a query to the SQL Server or to the Azure SQL database. What exactly happens behind the scenes? Let's say you have a store procedure, right? And that retrieves a lot of data, just retrieves a lot of data. So let's say that query runs for the first time. Behind the scenes, the query engine will actually, it will go ahead and use some information to allocate the capacities for to run the query, right? The capacities like the CPU, memory, how much it have to allocate for that particular query to retrieve the results. So let's say a store procedure is executed on the query engine. The query engine will go ahead and first look at the statistics. Statistics are nothing but a table-like structure, right? A table-like structure which will describe the distribution of the data within your table. These statistics are on the tables itself, and they just show, like, for example, if the statistics is on a particular column, it will, that particular statistics on that particular column will just describe how the data is flown for that particular column. Let's say for particular value, there are 10 rows. It will define that. For next value, there are like similar 50 rows. It will define that. So it will actually, it's just a distribution of the data that happens behind the scenes. Statistics you can create, or the SQL Server or the engine will automatically create those for you when you run the queries. based upon the usage of the columns, right? So what SQL engine will does is it will go ahead and allocate the resources, CPU memory, based upon the statistics values. And once those resources are allocated, then it will go ahead and execute the query. Then it will go ahead and create the execution plan for your query. So creating the statistics is not only the thing, you need to maintain those statistics, because if you have the OLTP systems, your data will be inserted, right? As your data is inserted, these statistics needs to be updated because the flow will change, right? So maintaining these statistics is really important. Let's say like you have stale statistics, that will actually affect the SQL engine to look at the old statistics which are not proper, and it will allocate the wrong resources. And then as we go down the lane, like creating the execution plans, it will go ahead and create the execution plan with wrong parameters, and that will cause performance delays, right? It will directly affect the performance of the query. But if the statistics are maintained properly, then it will get the actual data, allocate proper resources, and then the query will be running fine. So that's the importance of statistics. Now, what about the indexes? Indexes are used for the retrieval processes. It is not used for any other thing, like inserting or updating the data. But then something happens when you insert the data into the table is that these indexes also will be updated. Let's say you have the index on two columns, and when those two columns are updated, then the index also needs to be updated to, to have the updated data. And SQL engine will use these indexes to see like to get those selects properly, like to retrieve the data quickly. Even these indexes also have like all the data, like if you're creating an index on two columns, all the data of those two columns stays in the index. Again, it have like different structures within the index, but we are not going much deeper into that. But maintaining these indexes and statistics directly impact the performance. Now, enough talking about the indexes and statistics. Now let's go to the next slide. So we talked about indexes and statistics, right? These are in place in on-prem databases as well as in Azure SQL database. But how about maintaining them? Can we really maintain them when we have in Azure? On-prem, we have SQL Server agent, and you can go ahead and create the agent jobs to maintain these indexes. But in when we build a Azure SQL database, we will not get any SQL Server agent. But is there any way where we can maintain these indexes and statistics? That's when Azure automation will comes in play. We can go ahead and create the Elastic agent job to create these sort of automated jobs for the maintenance. So now let's see how to create these automation jobs. Let's take the example of maintaining the indexes and statistics, right? Not only the indexes and statistics, if you want to build any automated jobs on the Azure SQL database, you can use this format. Now there are certain prerequisites that you need to know, right? Um, so there are some scripts which are free and available online. If you go ahead and search for Ola Hellengren scripts, these are just the free maintenance scripts where most of the companies use to maintain indexes and stats. But if you already have something in place in your company, right, internal scripts, you can also use them. That's a prerequisite that we need to have. We need to execute these scripts on the Azure SQL database so that we have certain stored procedure built in place with these scripts. Next, we need to create an automation account, and then we need to download the SQL Server module from the marketplace. Very easy. And then we need to create the credential that will be used to run this particular automation job. And then go ahead and create a runbook, schedule the runbook, and use that runbook um, for maintaining these indexes and stats. Now, as I said, like we need to have the Ola Hellengren scripts. For example, these are the maintenance scripts I executed on the Azure SQL database, which created certain store procedure automatically as I execute the query. These are the store procedures that we will be using to create the automation job. Now we will go ahead and do the search in the Azure portal.azure.com. If you log in, if you do not have an account, you can open up a free account with certain credits that you can go and play with the features. But if you have a portal.azure.com account, go ahead and search for the automation account. Very simple. I'm not going through every little step of how to create, but I will exactly show you what you have to do because we have a lot more things to cover in this session. Go ahead and search for the automation account, and then basic things that you need are like name and then the subscription details. Of course, the resource group. Any resource that you create in Azure needs to have a place in the resource group. You can create any number of resource group, but it has to be a part of resource group. And then the region where you want your database to be hosted. That will be the exact region where you want your automation account to be hosted as well. And go ahead and click on create. Once you create it, again go to the search bar and go ahead and search for the SQL Server module. This is very simple, like the way you install the plugins on the Chrome, right? The extensions on Chrome. It's a similar way. It's just an extension. Next, you can just download this SQL Server module. Once that is in place, we need to go ahead and create a credential. That credential is actually available underneath the automation account that you built. So left side your pane, if you see underneath the automation account, go to the shared resources, and underneath that you find the credentials. Click on that and add a credential. Give it a name and password. Once you run that, you are ready to create a runbook. Underneath the automation account again, if you see the process automation on the left pane, you can see the runbook. So you can go ahead and click on create a runbook. But before doing that, you need to create two variables. Basically, you do not want to hard code the values in the runbook. So you want to create the database name as well as the SQL Server name, which is a logical server here because we get with the Azure SQL database. The only way you can connect to the Azure SQL database is by using the logical server. It is not the actual server, but it is just a way to connect to your Azure SQL database. It looks like the server, but it's not the server. Again, behind the scenes, Azure will actually use the server to place the database, but you have no idea where they are going to have that database. So logical server is just a way to connect to the Azure SQL database, nothing other than that. So we have created the variables here, database as well as SQL Server. Next, we'll go ahead and click on the runbook, create the runbook. And if you observe here, we have given the credential, the variables, SQL Server and database variable. And at the last line of this particular query, all you are doing is calling out the store procedure that we have been built by running the Ola Helen Green script. All we are doing is executing that, and we are giving the operation all to go ahead and work on all of the maintenance jobs and log to a table. And that's all we did. And then hit on save and create the runbook. Now you can go ahead and also schedule it based upon your needs and then click on create. And for example, here, I would like to show you like how to ad hoc. We can also run this particular job ad hoc immediately whenever you want. So let's say I have built two new tables. So I have built a table and I have inserted a lot of data into it. So as we insert a lot of data into it, your indexes needs to be updated as well as your statistics also needs to be updated. So when you have a database on-prem SQL Server, by default, these statistics will be executed, will be updated automatically if you have the auto update stats as turned on. This particular option, auto update stats, is always turned on by default. But in my demo, just to show you like how we have like to show you if these particular stats are getting updated or not by running the runbook, I just disabled that option. I just disabled the auto update stats as turned off so that they will not be updated automatically. So I have inserted a lot of data. If you observe the first picture, index fragmentation, the last column, average fragmentation in percent, two of the indexes are totally fragmented, 99.99%. And if you see like the second picture, that shows the statistics that are on this particular table. Again, just as one more thing to say, whenever you create any index on the tables, the statistics will be automatically create on that particular column where you build the index on. So there are also statistics. We inserted a lot of data, but they were never updated. If you see the second picture, all of them says as null. Now I'll go ahead and manually run that particular job. And then once it is successful, I'll go ahead and rerun the exact queries to grab this information of index fragmentation as well as the statistics information. Now you see the first picture, last column, they were updated. And then in the second picture also, they were updated. And if you see the rows sampled columns on the second picture, they were exactly the same. The number of rows in the statistics and the number of rows sampled. So the difference between both of them is like the meaning of like what is the meaning of row sample is like you are doing the 100% scan on those statistics. So the number of rows we have and the number of rows that we actually scanned to update these stats are 100% because both of them have the same number of rows. So that's how you actually create the automation job based upon your needs. Now let's see the other feature that we are going to discuss here is like query store. So query store feature is actually introduced in SQL Server 2016 on-prem, but eventually as a build Azure, it is automatically turned on in Azure SQL Database, as well as it is automatically turned on SQL Server 22, SQL Server 2022. So this is a database level feature. It's not a server level feature. And if you want to enable it, you need to go to the properties of the database and enable the query store. So what is this query store and what it actually do, right? So query store is a feature that once you turn it on, it will go ahead and collect all the stats information and all the performance related information of your queries while they are running. So it will, once you turn it on, it will go ahead and continuously collect the information of your queries along with those execution plans over time. So let's say one of your query is running fine and it has an execution plan. Once you turn the query store on, it will collect that information and it will put in the query store. And later down the road, another execution plan got created that is running fine, like better than the previous one. It will go ahead and store that one as well. It will collect everything. Like you can also compare between the execution plans and see like what is the difference between these two, like what seems to run fine. And that's the way it will collect the data. And you might be having a question like, okay, but where does this query store actually stores the data, right? Is it in the master database or is it in the actual database? It it stores the data within the database itself because it is a database level feature, right? You turn it on a database. So it will always collect the data on the primary data file of the database. Always on the primary data file. You cannot change that option. And you need to make sure like giving the proper amount of space on your query store because once it fills up, the query store will go to the read only mode. Do not worry that your queries will fail. It will never fail. They will never fail. They will run fine. But the thing is, the query store will go to the read only mode if it is full. So you need to make sure, like, the settings, the configuration part, you do it properly. So, but you might be asking me another question. Like, will we have those monitoring tools in place? Like, our company already have a monitoring tool where it will collect all the information, like what is the CPU, memory, IO information, and what are the execution plan information available for your queries. It's already there. What is the advantage of having this query store feature within the SQL Server or within the Azure SQL database? What's the advantage? Well, the advantage is that as it collects the data, right, as it collects execution plans. Let's say one of your queries was running very faster, but something happened in between, and developers are seeing certain like from the application side, the query keeps on running and it is causing the query timeout, and you don't know why. And your developer comes to you, like, because I'm a DBA, I will talk from the DBA perspective. Developer comes to a DBA and says like, hey, my query used to run very fast, and now it is having the query timeout, and I don't know why. And the first question that the DBA asks is like whether you did any updates, whether you updated any application, or whether you updated your database, or whether you changed any of the store procedures, right? And then he will go ahead and check those indexes and statistics, whether they are in place, because those are directly related to the performance. But he won't understand, like, apart from that, he won't understand. He will go ahead and see those monitoring tools, but he will only get that information from the database perspective. But he won't have a way, like, exactly to see how he can fix the problem very quickly, right? So by having the query store, he can go ahead and see like, okay, now the query is not running fine, but previously it used to run fine. So let me go ahead and see whether there are any more execution plans in the past which was running fine. Let me figure that out. And what is the current execution plan? And as a DBA, if I go there, I will find a new execution plan, because the execution plan that was currently running is actually causing the issue. But what was the previous one, which was running fine? Now I'll go ahead and compare both of them, and I can go ahead and manually force that plan. Meaning that once I click on, like, once I force that plan, next time the query runs, with no matter any parameter it runs, it will go ahead and use that particular forced plan. So that is how you solve the problem, by using the query store even without touching the code, without even touching the stored procedure. Well, that's beautiful, right? But then there is something we need to remember, that once we force a plan, we can't forget about this. Like, there might be several other scenarios where SQL engine will just throw away this query store and throw away the forced plan, and it will go ahead and forcefully generate a new plan. And you don't even know, right? Because as a DB and developer, we have several other things to do, and we can't focus on like whether a new plan got generated or whether the actual forced plan is being used. We can't monitor it 24/7, right? But then they added an additional advanced feature within the query store, which is known as automated plan correction, which corrects the plan automatically for you. This feature is available from 2017, and it is only Enterprise Edition, as well as it is automatically available in Azure SQL Database. So what this automatic plan correction does is, previously, we are the ones who have to go ahead and force the plan. But with the automatic plan correction, once it is in place, it will go ahead and automatically monitor your execution plans and the query executions for you, and it will always force the last good plan for you. You don't have to manually go ahead and touch any of that. Once it forces the plan, it will not stop there. It will go ahead and continuously monitor for the next runs, executions. And if at all there is another plan that got generated for any reason, and it just ignored the forced plan and it created a new plan, this automatic plan correction will go ahead and compare between those two plans, like, okay, whether the current plan is good or whether the last plan is good. Again, it will have the information of all of those execution stats, so it will compare, and then it will go ahead and always force the last good plan. So that is how, like, you do not have to worry about monitoring any of that. It will take care for you. Now, how do it actually works in reality? Now, I will show you in my demo like how the automatic plan correction works in Azure. Again, automatic plan correction is always turned on in Azure SQL database, but I would like to just show you like how if you are on-prem, how to enable it on your enterprise edition. Again, it is not available in any other edition. It is only available in enterprise edition, and it is automatically turned on if you are using Azure SQL database. So here I'm using AdventureWorks database, and we are using Azure SQL database here. Let me go ahead and connect. So I'm using Management Studio to connect to the Azure SQL database. If you see here, we are connected to the logical server, and we are using AdventureWorks database. Now let me show you how the query store folder looks like, because we are talking a lot about query store feature. Expand that. And then if you see here, if you are on-prem, you need to manually go ahead and turn on this in the properties of the database, but you're in Azure SQL database. So this folder is automatically available. If you expand that, you see all of these wonderful reports that it will automatically generate it for you. But let's say like top resource consuming queries, right click and view top resource consuming queries. Like any queries that I run today will be placed in here because the query store is automatically enabled. I don't like this this graph view. You need to actually go ahead and hover your mouse to see the query itself. And if you observe the query, it looks like the parameterized value. I would like to see the query clearly. So I would like to click on the grid mode to see the query itself. If you observe here, we have the query IDs. So if you have a store procedure and that store procedure have parameters in it, right? So that particular store procedure will only have one query ID, no matter what parameter you use. But if you are using ad hoc queries, it can generate and it can fill up your query store very quickly because each of the execution can have different query ID for those ad hoc queries. Even a simple space, even a simple comment, changing the comment can generate an entirely new query ID, which can fill up your query store very quickly. So you need to make sure um, how your configuration is important. And if you are by default setting up the query store, just make sure like you schedule a job which can go ahead and automatically clean up all the ad hoc queries for you. There is an article in Microsoft where you can go ahead and grab that query just to clean up the ad hoc queries within the query store. You can schedule that using the automation job. You can say you can use automation job to clean up that. But so I just want to put out there like ad hoc queries, not so good, but then we can't avoid them, right? Most of the times, like applications, they want to use ad hoc queries from their running from the application. You can't always avoid them. So this is how the query store actually looks like. If you say there is a plan ID for this particular query ID 10, we have a plan ID that got generated, and you can see what is a plan for that query. And if you hover your mouse on this particular dot, right, it will give you all of the execution stats information. And you can also change the metrics. All of these metrics are available. Like if you observe. So now let's go ahead and um, turn on the automatic plan correction feature on the database. So again, like in Azure SQL database, this particular automatic plan correction is already enabled, but I just want to show you how to actually do it in T-SQL, Transact SQL, if you're on-prem. Just do alter database name, set automatic tuning, force last good plan to be turned on, and then go. All right. Now let's go ahead and see what are the features that are actually enabled for the automatic tuning options in Azure. Do the select and this particular view will show. Execute. we need to execute in the database. If you see the results, these are the intelligent performance features that we are talking about today. Force last good plan is the automatic plan correction. The next ones are create index, drop index, maintain index. These are the automated intelligent performance that are also available in Azure, which we will see in the coming slides. But right now we are focusing on the force last good plan. The automatic plan correction is currently turned on, which is good. Now let me go ahead and simply create this particular store procedure. All I'm doing is like dropping if it is already exist, and I'm just doing the select on a couple of columns and filtering on the product ID. Now I would like to execute this. And then if you observe here, there is some data which is collected, right? Now I would like to go ahead and clear off my query store. Be careful, do not do this in production. I'm just cleaning out everything for my demo. So it will clean up all of the query store information that have been collected until now. So just alter the database name, set query store clear will actually clear the query store. If you see here and refresh the query store, now we have clean slate, so we can go ahead and execute our queries. So I'm also clearing out the procedure cache. Now you might be asking why you have to clear out the procedure cache. You know, from the SQL engine perspective, whenever a query is executed, like we have just created a store procedure, right? The next time we run the store procedure, the first time after creating a store procedure, the engine will go ahead and see, it will go ahead and create an execution plan for you. And it will place that plan in the procedure cache in the memory of the SQL server, right? So the next time you run the same store procedure with no matter what parameter you use, it will go ahead and directly grab the execution plan from the procedure cache. So for my demo have to work, it should not break. So I would like to clear out my cache. Anything there in cache, it will be cleared out. Do not run this in production again. And now I'll go ahead and create my workload. Again, remember this demo is for the automatic plan correction. We are not going to touch any code. I'm not going to touch the store procedure, but it will go ahead and force the good plan for us automatically. So I'm going to create the workload. That's all we do here to see how this particular feature works. So we can't just run the query for one time and then expect the automatic plan correction to take the action, right? So we need to create certain workload. So I'm running this particular store procedure with the parameter 942. Now, what is the speciality of 942 is because we have certain um, parameters here, like 942, and the next one is 707. These parameters are sensitive, meaning like 942 can give just like hundreds of rows, and the other parameter can give like millions of rows. So I'm like creating an entirely, I'm differencing how much of a workload difference we have between these two workloads. So the first workload, I'm running it for 50 times, right? Let me run this one. I should have enabled the actual execution plan. So if you see here, the executions like 50 times, each of those execution created 385 rows here. Now let me go ahead and turn on the actual execution plan and then run it again to show you the execution plan. So we got like how many rows per execution? We just got like, it's still running, 385 rows, couple of rows, and it choose index seek and key lookup, which is good, for just for 385 rows. All right, now let's go ahead and see what's there in our query store. Refresh and see there is only, we have run for about like 100 times, right? I rerun the exact thing workload again. So, but still we just saw the query ID, just one query ID because we are running the store procedure. And then it got the plan ID 1. And if you see the circle, size of the circle is bigger because if you observe the execution count by hovering your mouse, it says the execution count is 100. The more that you execute, the bigger the circle is. And you can see the all the stats over there, right? Now let's go ahead and run the second workload. But again, I would like to clear out my procedure cache because I want to make sure my engine is forced to create a new plan for this. I'm going to clear out my cache and then I'm running the second. I'm causing the regression, right? Now this execution will generate like too many rows. If you see here, um, we are only running a couple of times. Now, if you see here, 237,000 rows per execution. And if you see the execution plan, because we because we cleaned up the plan cache, it went ahead and generated a new plan. If I would not have the clean up the cache, right? You do not have to do this in production. Like if you are enabling the automatic plan correction, do not do this. Like you do not have to worry about cleaning up the cache. The automatic plan correction will take that, but I want to make sure my demo works. I don't want to break my demo, so I just make sure I clean up the cache. But here it used the clustered index scan. Previously, it used the index seek and key lookup for that particular 385 rows. That is perfect. But here it is perfect in this scenario because did you see the number of rows that it is pulling per execution? It have to scan the entire index. Good. Now let's go ahead and refresh, right? Are you ready to see if it is being forced? Refresh and see something happens right side your screen on the graph. If you see, there is a little tick mark on the green color plan ID. If you see here, there is a little tick mark. I did not make any changes, right? I did not touch the code. So what it does was like this particular little tick mark indicate that this particular plan ID 1 is currently being forced. Now, if you see, like if you want to compare, like if you hover your mouse over there, right? And see the total duration, and if you see the average duration, minimum duration when compared with the plan ID 2, the total duration is 5,342, which like automatic plan correction thought like, okay, this particular plan ID 1 was executed for 100 times, more than 100 times, and the second one executed like 10 times. Like 10 times, we just executed 10 times, and it went ahead and compared. So how do we compare it manually, right? Just go ahead and click on Shift and click on both the plans, and then there is this little like uh, focus button here, compare the plans. Click on that to actually compare between the plans. You can manually compare, but then the automatic plan correction has actually compared that for you, and then it went ahead and forced that last good plan. So you can compare all of these stats information like the execution, um, like the resource consumption information and all. You can go ahead and compare between the plans as well as the properties. Now, like I said, it went ahead and it forced the plan for you, which is good, right? Now that's how the automatic plan correction works. It will continuously monitor, and then it will, wherever it sees the regression, lot of difference, it will go ahead and compare and always make sure the last plan is the good one. Now, how do we know like why it has actually forced the plan? Because too many queries runs from our applications, and how do we know like why it has actually forced a particular plan when compared with the other plan? There is this particular view you can run on the database. Select star from sysdmdb tuning recommendations, and if you execute that, now it says like force last good plan turn on, and the reason why it decided to force that plan was like average CPU time has changed from 1.73 milliseconds to 874 milliseconds. It saw the too much difference between the two execution plans, and so that was the reason why it decided to force the plan ID 1. And if you hover if you drag your mouse to the right side, there are the details. If you can copy the details and then paste it here, it has actually given you the exact script that it have executed to force that particular plan 81. So to force the plan, right, we use the execute sp query store force plan, give the query ID. Did you see here the query ID? This is the query ID. Give the query ID and then the plan ID. This is the plan ID one. So if you're manually forcing, right, without using the automated plan correction, this is the query that you run from the T-SQL. So what I suggest was like always use the transact SQL query to force to force the plan manually. Now, the reason why you can also do it from graphical user interface if you are manually doing it. But the thing is, this information won't be captured in your monitoring tool. Like if you are using any monitoring tool, right? That thing won't be captured, and you won't even know like who actually forced a plan. So it is always important to make sure like you run these sort of things in transact SQL. So that is how the automatic plan correction works. Now let's go ahead and quickly see how the query store hints work. Now, um, I'm going to use the same AdventureWorks database, and then my this particular query is currently connected to the local server. I'm going to change that to the logical server, Azure SQL Database, and I am going to connect to the database, AdventureWorks, and then I will go ahead and drop and recreate the exact same store procedure that we were using. Now I would like to, now you might be asking, we already have that store procedure. Why did you even recreate it? We already have, that's the same database, right? But the thing was like, I would like to force the execution plan to create a new execution plan for me. So I would like to clear out my query store again. If you see here, let me close this one. Drag this one here. We have this particular query. So let me go ahead and clear out my query store as well as the procedure cache. All right. Now, you know that we have certain parameters which are really sensitive for the store procedure. Now let's observe. We have recreated the store procedure and I'm running this particular store procedure with this parameter for the first time after creating the store procedure. And I'm also running the second execution. Now let's turn on the actual execution plan on and let's execute this and see the difference between both of them. The first execution gave like 360K records. The second one just 385 records. And if you see the execution, remember the first one is like 360,000 records, which thought like doing the index scan because huge number of rows that we are pulling, right? But then if you observe the second execution, for 385 records, it went ahead and did the same index scan. Now, why is that, right? Why is that? Because like I have created a store procedure. I have executed the store procedure for the first time with a parameter. That went ahead and created this execution plan, and this plan is currently in place in the plan cache. I told you, right? We have, whenever the query engine will generate the execution plan, it will go ahead and save that execution plan in the procedure cache. Now, the next time, no matter what parameter it uses, the next runs will always go ahead and grab that plan from the plan cache. If the plan that was saved in the procedure plan cache was a bad one, like if you see here, one of the rarest parameter that we execute from our application will execute too many records, but that is just one parameter. And rest all the executions will only give us like 385 rows or like couple of hundred of rows. Now, what if after creating your store procedure or after you're recompiling your store procedure, the first time you run the store procedure is a bad parameter, and it generated this particular plan scanning the entire index, which will take huge number of resources to execute the query. That will affect, right? Because the next executions will always go ahead and use the same bad plan, which is not good because all we want to get is like most of the parameters we have for the store procedure will get only couple of hundreds of rows. And because of this bad plan, now it allocates too many resources to execute this particular store procedure plan, which is bad. What is a resolution for this? What do you do generally? Like if there are any developers in this class, what do? You will just go ahead and recompile, right? Because recompile will go ahead and force the execution plan to regenerate a plan for you. And the best case, you are executing the good parameter. Like most of the parameters that you have for your store procedure, you are using the good, assuming you are doing the good, right? But again, some other time you execute bad parameter after like recompiling, then again it will go ahead and save the bad plan. Not good, too much less control. And if you want to change that, you need to go ahead and recompile and you need to go ahead and touch your code. And not always your vendors might not be happy about it. Like whenever the query is not running fine, it is like too good and too bad situation. If the parameter, the first time that you run the store procedure, the parameter is good, you get the good executions. And then whenever the execution is bad, you go ahead and do the recompile, and not all the time your your vendors are happy about it. They don't want to change the code. You're not allowed, or you're not allowed to touch the code, but you are allowed to fix the code, which is like, what? Right? But the thing is, like with the query store, query hints feature, you do not have to touch the code. Even without touching the code, you can solve this particular parameter sensitive problem. Now, how do you do that? You can do that um, in like there are certain store procedures designed for this in the for the especially for the query store. All you need is a query ID, right? You just need to have this particular query ID and what hint you want to use to fix your problem, right? The parameter sensitive problem. So to get that particular query ID, you need to run this particular query. All that you are doing is you are searching on the query text of your store procedure. Now I'll run this particular query, the query ID 1. That store procedure have query ID 1. And then now all you will do is you will execute this particular store procedure. SP query store set hints is especially designed to use the query hints without touching your code. So you execute this particular store procedure, give your query ID 1, right? We grab that query ID from here. And then in this particular case, I want to use the option recompile. So you have to have two parameters available. One is the query ID, which we got here, and the other one is the value. What query hint you want to use. So I want to use a recompile in this scenario, right? Because the first one, like, the first execution that we executed here has did the entire scan. We don't want for the second one to have that because we are only getting few rows. Now I'll go ahead and execute this one to recompile the store procedure, right? So let's execute that. And now let me go ahead and execute the same exact parameters, like execute the store procedure with same exact parameters. Now let me execute and see if there is any difference. If you see the execution, the first execution gave like 360,000 rows, which is good to do the index scan to grab the details to get the results. But the second one, which is like 385 rows, did you see the difference? It recompiled and it generated index seek and key lookup, which will require less amount of resources. If you see the query cost, 2%. If you see the query cost here, 98%. So the second execution, only 385 rows, it recompiled and you did not even change the code. That's how you fix a problem by using the query hints. And if you see like, if you want to know like what query hints are active on your queries, run this particular view again to see like what are the current query hints that are active. The query hint ID 1 and the query hint is option recompile, right? That is what we just executed for the query ID 1. All right. Now let's go ahead and think like I would like to use another example of the query hint, max top one. Now I would like to force my query to just use the max top one, right? Now let's go ahead and execute that. Still the query ID is one, but the value has changed from recompile to max top one. Let me go ahead and execute that. And I would like to clear out my cache and then rerun those two executions again with the same parameters. Now let's see the execution plan. Now if you observe here, right, we just changed the query hint from the recompile to max top one. And that was the reason why, again, we see the similar. The first execution for 360,000 rows did the clustered index scan. The second one, no matter what, 385 rows, doesn't care. It went ahead and grabbed that plan from the plan cache. But as our hint is currently max top one, go ahead and see the properties whether it is actually applied. If you see the max top one here, non-parallel plan reason is max top set to one because we requested engine to go ahead and use the hint max top one. Now, what if you want to use both of them? Because the max using max top one has removed the recompile option, right? Now, what if you want to use both of them? Option recompile as well as max top one. Now, let's execute that and rerun the same executions again after clearing out my procedure cache. Rerun those two executions again and see the execution plan here. Now, the first execution, it used the clustered index scan, which is good, right? The second index seek and key lookup, it recompiled, right? It recompiled, but whether did it use the max top one as well? Let's see. Yes, it used the max top one on both of them. If you see the properties, it used the max top one. So you can use the multiple query store hints together. But if you want to see like what are the hints that are available, if you observe here, now the hint from hint ID 1 has changed to hint ID 3 on the query ID 1 with the hint text. But what about the history of the hints that we used? First we used recompile and then we used maxstop and then we added both of them together in the query hint, right? What about the history? The history is not saved within the SQL Server, but there is a way that you can save the history of the information like query store hint information by using the extended events. I have an entire blog post about it, like a blog post about how exactly you can go ahead and create that particular extended event to capture specifically this information, the history of the plan, like query hint information. You can go ahead and search on dbanuggets.com. Underneath the query store tab, you can find that blog post. So what are the other query hints? Like what are all the query hint list of query hints that you can use here with the query store? Go to this website to see like the active hints that you can use. So that's a demo for my query store. Now let me go back to my slides. So that is a wonderful feature where you can use the automatic plan correction as well as the query hints. But just remember that the query hints, using the query hints is only the temporary fix to fix the problem without touching the code. But if your query itself is terrible, if you are a DBA, you need to go ahead and work with the developer, giving them all the standards of how they have to exactly create the store procedure for the faster execution. Because as a DBA, you are the one who exactly know how to improve the queries and what are those techniques. So it is always advisable to go ahead and um, refactor your entire code to run it faster. But this using the query hints is an immediate fix until you solve the problem by refactoring the code because it takes time to rewrite the entire code. Now let's go ahead and see the other intelligent performance features that we have. I went ahead and I clicked on the Azure SQL database within my portal. And left side your pane, if you see, like you'll see the intelligent performance um, tab over there. Of course, it is not showing in this screenshot, but we'll see in the next screenshot. Under the intelligent performance, you have like create index, drop index, um, alter index, those sort of recommendations that you get automatically. But it is up to you. It will just give the report. You can go ahead and look into what are those recommendations and then take the action if you want to. You can ignore as well. So here it says like notifications. Underneath the notifications, it shows as create index. So like within your database, Azure SQL database, left side your pane, underneath the security, like underneath the intelligent performance, not the security. Under the intelligent performance overview, it shows you the recommendation to create something, to create the index. Now click on that to see more details. It shows like create this index on this particular table and these particular columns and what is the impact. It says like high impact. Now you can go ahead and automate on the top. You can click on automate to automatically create this particular index, but you can also discard this particular um, thing if you not like to go ahead and take the action. But if you click on that particular index, right? If you click on that particular index, you can clearly see the details on what is the index name, type, and then schema, table name, and if you have like key columns, if you have any included columns, all of that information is in place. And you can right away apply it from here on the top. Underneath the create index, there is like apply button over there on the top, but you can also discard it if you do not want to create it. But that is a report, like how it will show you like any recommendations. That is not available in on-prem SQL Server databases. And the query performance is insight is one of the other feature that you can use. Again, underneath the AdventureWorks database, underneath the intelligent performance, remember we have seen all of these features are under the intelligent performance. Under the intelligent performance, go to the query performance inside, which will show you a graphical user interface where you can see all of your queries that are executing on your database along with the resource consumption information. On the bottom of the screen, these are all the queries that got executed and execution count, duration, and resources like CPU, IO, log IO, all of that information is available. Let's say we want to click on query ID 61 to see more details. It will give you the exact query that got executed and what are the resource consumption information. And on the top, if you see there is a recommendation tabs. So on this particular queries, it can also give you the recommendations like if there is an index that can that can be helpful to improve the performance, it is shown under the recommendations. And I think I covered all of the features that are currently available in Azure SQL database, especially. So I hope you enjoyed the session and learned something from this session. And I hope to see you all again in this community speaking on some other different topic. But thank you so much, Suraj, for giving me this wonderful opportunity. Thank you.
Thank you, Deepti, for the session. I think we went over a lot of topics and we went over a lot of tips and things you should be doing. And I hope you were able to understand everything as well. And thank you for taking the time as well from Deepti and all of you who have joined us, even though the time is a little bit late for the APAC region, everybody, we still had a really good number of people who are joining. Thank you for that. And special thanks to Deepti for the session and to taking her time to explain everything and being there for us. Okay. And this, I'll be sharing the link to getting your certificate of participation chat box, and you can fill out and get your certificate of participation. And Divya have also sharing her LinkedIn and her Twitter ID. Please do give a follow there so that she'll be updating about the new technologies and in her social media as well. So you can give her support there. Awesome. And if you want to be participating in the upcoming session, please do join the community and I'll be sharing the link in the chat box. And again, thank you all for joining and Have a great rest of the day to Deepthi, and good night to all who have joined from the APAC region.
Thank you all.
Thank you.